Hey everyone, and welcome. Today we are diving deep into one of the absolute superpowers in any programmer's toolbox, Python loops. And trust me, this isn't just some dry coding concept, this is all about unlocking the true power of automation.
So let's just jump right in with a real-world problem. Picture this. You've got 1,000 photos you need to resize, or maybe 1,000 reports to generate. Are you really going to sit there and copy-paste your code 1,000 times? Yeah, no way. There's a much better way to handle that.
And that, my friends, is where the loop comes in. A loop is simply a way to tell your program, hey, see this block of code? I need you to do it over and over again. It's literally the difference between doing a task by hand and building a machine to do it for you.
So how do we build this automation machine? Well, in Python, we've got two main tools for the job. Two real workhorses of iteration, the for loop and the while loop. So let's dive in and break them down.
Okay, so the main difference between these two, it's actually pretty simple when you think about it. A for loop is kind of like an assembly line worker who's been told to process exactly 100 boxes. They know when they're going to finish. A while loop, on the other hand, is more like a bouncer at a club who lets people in as long as the club isn't full. They don't know when it'll end, they just keep checking that one condition.
Let's look at a for loop in the wild. When you see for in range 5, you can literally read that as an order. Hey Python, do this thing exactly 5 times. It's super predictable, it's precise, and it's perfect for when you know exactly how many times you need to do something.
All right, now let's flip over to the while loop. This one doesn't have a set number of runs. Instead, it just keeps asking a question over and over again. In this case, is the variable a less than 10? As long as the answer is yes, the loop keeps on running. This is so powerful for situations where you don't know the endpoint.
Okay, so that's the theory, right? But let's be real. Loops really come alive when you start throwing actual data at them. This is where the magic happens.
You know, this is probably one of the things you'll do a million times in Python. You have a list of stuff, and you want to do something to each and every item. The for loop makes this feel so natural. For item in fruits. It's almost plain English, isn't it? For each item in my list of fruits, go ahead and print it out. It's just so clean.
And what about dictionaries? They've got those key value pairs, right? Well, a for loop, especially with that little .items method, is just perfect for this. It neatly unpacks both the key and the value for you in every single pass. Super convenient.
Okay, but let's level up. What happens when your data isn't just a simple one-dimensional list? I mean, what if it's more complex, like a grid, a matrix, or yeah, the pixels in an image, which have both a row times a column? How do you deal with that?
Well, the answer is something called nested loops. It's exactly what it sounds like. A loop inside another loop. The outer loop takes care of the rows, and then for each of those rows, the inner loop runs completely, taking care of every single column. This is the absolute key to working with any kind of 2D data.
All right, we've got the basics down. Now let's talk about adding a little more finesse, a little more control, because sometimes you don't want a loop to just blindly run from start to finish. You need to be more precise.
So, break. Think of this as your big red emergency stop button. In our example, the loop is supposed to run 10 times, but we've added a rule. If our counter I ever hits the number 5, bam, hit the brake. The entire loop just stops, right then and there. It's perfect for when you find what you're looking for and don't need to check the rest.
Now, continue is totally different. It's not the emergency stop, it's more like a skip button on your music player. When the code hits continue, it just abandons the current step and jumps right back to the top to start the next one. So here, it'll print 0, 1, 2, but when I is 3, it hits continue, skips the print, and jumps right to 4.
So you might be thinking, okay, loops are cool for lists and stuff, but why is this so important? Well, here's the kicker. These super simple ideas are the absolute engine behind some of the most complex technology we have today. And I'm talking about artificial intelligence.
You know, whenever you hear someone talk about an AI model learning from data, what's really going on under the hood? It's just massive, mind-boggling repetition. And what does repetition? Loops do. They're what churn through huge datasets, process batches of images, and most importantly, they run the training process over and over again, making the model a tiny bit smarter with each pass.
And in the world of machine learning, this whole process is often broken down into epochs. What's an epoch? It's just one complete trip through all the training data. A model might need to do this thousands of times to actually learn something useful, and it's a simple for loop that drives that entire training process.
Okay, let's switch gears. I want to give you a quick interview cheat sheet. Let's boil everything we just talked about down into some quick-fire, crystal-clear answers that'll make you look like a pro.
First up, the classic, the one you're almost guaranteed to get asked. What's the real difference between a for loop and a while loop? And here's your perfect answer. Use a for loop when you know exactly how many times you need to run, like for every single item in a list. But you pull out the while loop when you're waiting for something to happen, when the loop needs to run until a specific condition changes.
All right, next question. We definitely touched on this, but let's really lock it in. What are nested loops actually for?
Simple. They are your go-to tool for working with anything that has more than one dimension. Think matrices, grids, tables, and of course, images with their rows and columns of pixels. Anytime you have that kind of structure, you're going to need nested loops.
And that's a wrap. We've gone all the way from a simple idea of just repeating a task to seeing how that very same idea powers artificial intelligence. It's amazing, right? A simple concept with huge implications. So I'll leave you with this question. Now that you have this power of automation at your fingertips, what are you going to build?